Welcome everyone. This is Airport Rescue and Firefighting Operations Training, or ARF. My name is Nico Stavros for anyone from maybe Opelika or police, whoever happens to see this that doesn't know me. I'm Nico Stavros. I'm a full-time student firefighter for the city of Auburn. I'm also finishing up the professional flight program at Auburn University here pretty soon, hopefully the next few weeks. And I created this training in PowerPoint to get some training basics such as navigating around an airport, general operations from the airport, taxiways, driver training, and talk about some Auburn SOGs between Auburn and Opelika, and other important information you should know as a department. And there's a lot. I know this presentation is very long. I really think it's beneficial that everyone goes through it at least once. But there's a lot to go over, so I know it's long, but just hang in there. Some of you may have taken ARF certified courses in the past. This is not a ARF certified course. This is just a informational seminar. It's not recurrent training or anything like that. I'm just including points from previous responses so we can learn from them. Hopefully not make any accidents in the future. Including information about general aircraft operating in and out, fuel systems, how to shut down engines, all that. And we'll go over the plane here in a second. I've also included my email and work phone, so if anyone has any questions, they can shoot me a text or an email, and I'll get back to them as quickly as I can. Also include some references, so National Fire Protection Agency standards, FAA standards, and hopefully make this PowerPoint as accurate as possible. Again, if anyone has any questions, shoot me a text or an email, and I'll do my best to respond. Here's the plan. We'll go over airport familiarity, some driver training, and how to identify taxiways and runways, as well as communication and radio usage. We'll go over aircraft basics such as pressurization, fuel, and some other important notes and hazards when operating around that airport. And we'll hit on some SOGs between Auburn and Opelika. Like I said earlier, just getting everyone on the same page. Go over alert levels, triage areas, media staging areas, and we'll go over that all in a second. All right, aircraft rescue and firefighting, or ARF. So we're not an ARF department, but I will get into a second here why it's important we should be proficient with the airport operations as a fire department. So an ARF department is any sort of department that's stationed at the airport and is regulated under Part 139 under the FAA, or the Federal Aviation Administration. There's very strict regulations that go along with that, such as tools, trucks, training. They have to do certain training scenarios. So every 12 months, there's a live fire training scenario they have to do. Birmingham, Montgomery, Huntsville Airport. These are all airports that have ARF units and are regulated under these strict regulations. And they have fire departments that are stationed at the airport. So it's important we fully understand operations around our airport because Auburn is the top two busiest. So most of the time, it'll be the busiest airport in the state of Alabama in terms of arrivals and departures. But sometimes we're second to Birmingham. But regardless, Auburn is one of the busiest airports in Alabama. We don't have an ARF department, and we also have a flight school, so that creates other risks when there's student pilots flying around in one of the busiest flight schools in the nation. So let's look at how quickly Auburn is growing as an airport, because I have no doubt this will soon be the busiest airport in the state by far. And as you can see here, Auburn's grown exponentially in the past months. So January to March of last year in 2023, we had around 18,500 operations in just a few months. And this year we've seen upwards of 22,000. An operation is considered either a landing, a takeoff, or a missed approach that is tracked by Auburn's operation software. It's called VerTower, or VerTower, something like that. Auburn is a very busy airport, and we play a very important role in the safety of this airport, so it makes things harder when the response is a joint effort between Auburn and Opelika. But that's why we're conducting this training to make things clear and the response effort is just a lot more smooth. So starting off, let's talk about some airport basics. There's two main documents that we need to be concerned about as a there's the ACM, or the Airport Certification Manual, which that's a little outside the scope of the lesson. But what we're more concerned about as a department is the Airport Emergency Plan, or AEP. Some might call it an ERP, or an Emergency Response Plan, but for the sake of the lesson, we'll call it an AEP. The AEP is normally located in the ACM, but it can be a standalone document. In our case, it's a standalone document. And the AEP will assign emergency responsibility and response coordination. And it's a little cookie cutter in at the Auburn Airport. That's because we're not under ARF regulations or Part 139 regulations. We have Chief Datnoff from Auburn and Chief Johnson from Opelika who developed their own SOGs that expand on this AEP. And like I said, I'm going to skim over these documents. It's a little outside the scope of the lesson. But what we're concerned about is understanding general airport basics, where to station personnel, and understanding the fundamentals on how to respond is huge. For the meat of the training now, we're going to talk about airport basics, controlled versus uncontrolled fields. The only difference between a controlled field and an uncontrolled field is that a controlled field has a tower and that tower is in operation and it's not closed or it's open. It's open for operation. A uncontrolled field could have a control tower, but if that control tower is closed, for example, let's just say it's 12 a.m. at night, that control tower is not in business hour, it closes, that is still considered an uncontrolled field, even though it has a control tower. It's still considered an uncontrolled field because if there's no one giving clearances, then it's considered uncontrolled because there's no tower in operation. So believe it or not, Auburn doesn't have a control tower at the moment, and there's a lot of airports that don't have control towers. And the procedures are a lot different if there's an active control tower or if there's not one or if it's not in operation. And Auburn is in the process of getting a tower. The as of August of 2024, Auburn does not have a control tower. But starting, they originally said August 12th, we were going to get a temporary tower, which is literally just it's a little room that a guy sits in and gives clearances to, and he'll be on the airport. But that'll start August 16th. It originally was August 12th, and about 2 years from now, we'll get an actual tower. They're in the process of planning to build it now, and that tower is expected to be. It's going to be part-time operations, but I believe it's going to be around 8 a.m. to 7 to 8 p.m. at night. And once it closes, that Auburn's field will then convert back to uncontrolled field. So that's why it's important that we know the difference between controlled operations and uncontrolled operations, because that depends if we have to contact the tower or not, um, or if we have to contact the common frequency. So let's talk about that here. If it's a controlled field, you are going to contact the tower and you're going to get a clearance to taxi on any sort of taxiway, cross a runway, anything around the airport. You need a clearance from a tower on a taxiway or a runway. When that tower is closed or if there's no control tower, then you will make a radio call. If you don't have a ground radio, then make sure you're talking to a battalion chief or incident commander, whoever has a ground radio. Maybe it's airport staff, or anyone that has a ground radio. Just talk to them, and they will make radio calls for you over the Common Traffic Advisory Frequency called CTAF, and make sure if there's no tower in operation, especially even if there is a tower in operation giving you clearances, just looking both ways before you cross runways, being very vigilant about traffic around the area. Because like we said earlier, Auburn's extremely busy. There's a lot of students that fly in and out of there, and it can get very busy. Just to reiterate, control tower, all operations, whether it be an aircraft landing, taxiing, taking off, or you as an emergency vehicle, has to be cleared by the tower. At an uncontrolled field where there's no tower or a tower is not in operation, so example, Auburn at night, then aircraft and you as an emergency vehicle will be required to communicate on the CTAF frequency. And it's more of a see and avoid system rather than a tower giving clearances for you to go wherever you want to go or for an airplane to come in to land. Talk about taxiway signs. If it's got a black background, that means that's the taxiway that you're at. So right there, it's showing us that we're on taxiway alpha. And if it has a yellow background, that means that you're turning, for example, in this picture, we're turning right onto Charlie. So black background, where you're there. Yellow background, you're turning onto that taxiway. Runway markings. So if you're on the double solid line so if you're on the left side of this picture right here, that means that you're about to enter an active runway. It's kind of like how highways work. If you're on the double solid entering the dash, that means you're about to you either need a clearance or you need to talk to someone and look both ways to make sure that runway is clear. And if you're on the dash side, if you're on the right side, going onto the double solid or the left side, that means you're exiting a runway and you don't really need a clearance for that. Just exit the runway, and if you want to, you can make a radio call saying Auburn traffic, emergency vehicle, clear of runway 36, for example. The ILS critical area or the instrument landing system critical area is an area trucks have to hold short of in order to not block ground landing equipment. That way, aircraft can use it to land, and it'll typically only be used in low visibility conditions. But personally, I'd always hold short of this at all times just because some aircraft use this, even in good weather, to gauge where they should be when coming in to land, especially when they're using autopilot. Let's just say an aircraft has a stuck gear. They're going to be coming in. If we're there, there's going to be some sort of incident with that aircraft, whether it be a gear stuck, a failed engine, something wrong with the aircraft. And most often than not, that pilot may use and possibly use an autopilot to help them down to the runway. And not all aircraft are equipped with GPS systems that'll use GPS approaches. So they'll use that ground equipment to help their aircraft guide itself down to the runway. So I would always hold short of this critical area. It looks like up there, that picture that we have of that yellow ladder on the ground, and we'll show everyone what it looks like at the airport. And once the tower is in operation, they will specifically tell you whether you're cleared to cross that critical area or not. But like I said, personally, I would just hold short of it at all times if the tower's not in operation. But the tower will tell you when it's in operation during the day. All right, talking about no entry signs. They're used to indicate areas aircraft should not enter and are only permitted to ground vehicles. I believe Auburn doesn't have any no entry signs, so it's not super important for Auburn in particular, but just understanding what those are. Taxiway signs, like I said earlier, if it has a black background, that means that's the taxiway that you're on, and if it has a yellow, that means you're turning on to that taxiway. I kind of threw in this last little quiz here. It shows Tango in a black background, and then it says in red bold letters or numbers 1836, which that means that you're entering runway 1836. If it's in red, you're entering a runway. And then we'll talk about the next slide here, just some general aviation lingo, just so if you can kind of paint a picture in your head on if someone's turning crosswind or downwind or base. But here's what a standard traffic pattern would look like. Here's the runway here. The aircraft's coming in to land to the east. So how it's going to look is an aircraft, when it takes off, will be on a departure leg. It'll be on a departure leg, and if it's remaining closed to the airport, coming back into land, it's going to then be on an upwind leg, turn crosswind. It'll then turn the opposite way that it's landing, downwind. And then once it's entered on the downwind and established, it'll turn base. And when that's key here is that when you hear an aircraft is turning base, you know it's getting ready to land here in a second. And then once it turns final, you know it's going to be within 3, maybe 5 miles of the airport. It could be farther, but you know that it's getting configured to land to land on the runway. This is important just so if you're listening to the radios, you understand where the airplane is. This is generally how most aircraft are coming to land, is that if they're coming in from a different airport, they'll enter on the downwind, turn here, turn base, and then they'll turn final. And I'll tell you right now, a lot of accidents happen at these airports from the base to final turn, especially when you've got a critical situation such as a stuck gear. A lot of times, an engine can cause a lot of difficulty turning base to final. So this is why we've talked about this a little bit, staging trucks ahead of the final area approach on any sort of road, whether it be on runway 18 or runway 36. Just staging a truck here so that when these aircraft come in, turn from base to final, there's a high likelihood that the aircraft could crash unless there's a proactive pilot that knows what they're doing. Because when you're banked in an airplane right here, it's very common for pilots to kind of overshoot final sometimes and have to overcorrect. And when they're overbanking, it can cause potential spins or stalls on final. And that's just a little important note for first responders there. So, yeah, we talked about the 5 phases of traffic patterns: upwind, crosswind, downwind, base, and final. An aircraft will land on a runway depending on the wind direction. For example, if the wind is reported 020 or let's just say 340 at 9 knots, an aircraft will land on a runway 36 for the most headwind. This helps with landing performance. So if wind is reported at 340, that means the wind is coming from 340, and aircraft like to land with more of a headwind, so the wind coming kind of more this way. And when that aircraft has more headwind, it just allows for more lift over the wings, more performance. So if you are able to get the weather ahead of time, you can kind of tell where that aircraft might end up and on which runway. So runway names are in accordance with their heading. So and the last number is taken out. So it's not rounded up, not rounded down. So for example, this runway right here is lined up with east and west. So this would be 270 heading west and 090 heading east. Let's just say, for example, it was slightly tilted to 278 degrees. So it's kind of a little bit more at a slant here. So it's kind of coming down like that. So what would happen is you would not round up. You just take the 8 off. It'd be runway 27. Understanding radial usage is also a key element. We've gone over radial usage. So for example, at Auburn, it'll be with no control tower, it'll be Auburn traffic because that's who you're addressing. Because if there's no control tower, you're addressing the traffic around that airport. So it would sound something like a radio call from an aircraft coming in. Let's just say this aircraft has let's just say it's having engine issues. If an aircraft's coming in, a Cessna, it'll say Auburn traffic, Skyhawk, 863 Alpha Uniform. That's their tail sign or a tail number. They'll say turning left base. So that means they're coming in on downwind. Typically, they'll be turning left base, runway 36, Auburn. That means that they're coming in to land on runway 36. So it'll typically sound like they'll be coming on the downwind, Auburn traffic, Skyhawk 863 Alpha Uniform, turning left downwind, runway 36. Auburn traffic, Skyhawk 863 Alpha Uniform, turning left base, runway 36. Auburn traffic, Skyhawk 863 Alpha Uniform, turning final, runway 36. Auburn. And that tells you that they're on final. So understanding radio usage is very important just to kind of build spatial awareness around the airport when you're listening to radio calls. Controlled airports, you need a clearance, and uncontrolled airports, you do not need a clearance, but you need to let other people know what you're doing over that CTAF frequency. Like I mentioned, Auburn will have a part-time tower, which means at night, somewhere around 7 to 8 p.m., it'll become an uncontrolled tower, or uncontrolled field, sorry, until around 8 a.m. in the morning. And then the controlled tower will open back up, and it will become a controlled field. We talked about the general radio call layout. Who you're talking to, so Auburn Tower or Auburn Traffic, depending on if the tower's in operation. So Auburn Tower, who you are, emergency vehicle, where you are. So if you're on the ramp, you could say, ramp, then your request. So it sounds something like, if the tower's in operation, Auburn Tower, emergency vehicle, FBO ramp, request taxi, runway 36. And typically, if there's an emergency, the tower will immediately say you're clear to taxi, and you can just say clear to taxi over the radio, and as long as there's no miscommunication there, just get your point across. That's what we need to do. Just get her point across. The most important guideline in airport is just to listen. If you have a ground radio, not everyone might have a ground radio, but making sure that incident commander is communicating what's going on if they have a ground radio to other emergency personnel across the airport. Standard aviation terms, making sure if you're over the radios, you're saying affirmative, negative, Roger, not Auburn's clear. If you say clear to a pilot over the radio, they won't. They're also painting a picture in their head of what you're doing on the ground as an emergency vehicle. So if they hear, emergency vehicle is clear or any of that, they won't know what you're talking about. If it's better just to use lingo such as affirmative, Roger, negative, say again, holding short, standby, advise intentions. All these are lingo to use so that way, not only you as a first responder, but also the pilots coming in know what your intentions are. These are a bunch of different phonetic alphabet letters. The main ones that we need to be concerned about is Alpha, Bravo, and Charlie, just because those are the 3 taxiways Auburn operates with. So instead of saying I'm on taxiway A, because it's kind of hard to hear that over the radio sometimes, you just say I'm on taxiway Alpha. Here's kind of a more self-explanatory slide. My goal is to kind of put these in the trucks so that we have these in the event that A lot of the trucks might not have either ground radios, or if your ground radio isn't working, what'll happen is when the tower's in operation, they will give you a light gun signal depending on your request. If you want these instructions or these light gun signals, you're going to point your truck directly towards the control tower, turn on all your emergency lights, and flash your headlights. And that will signal the control tower operator to give you light gun signals. So if you are, you need a taxi, then they'll give you a green light, meaning that you're cleared to go, and then you'll go based off of the colors they give you. And the main ones you really need to be concerned about is just green and red. I mean, maybe white if they're telling you to return to the airport or return to the starting point. But really, the main two ones is green and red. If they give you a green signal, that means you're good to go. If they give you a red signal, maybe another aircraft's coming to land, they don't want you going, or anything like that. And flashing red is obviously very important. If they give you a flashing red signal, that means to clear the runways, maybe because they can see on their radar someone else coming in to land or their scope. Now we're going to get into some basic engines and aircraft. There's three main categories and three main basic types of engines when we're talking about airplanes. Most aircraft at Auburn are general aviation reciprocating aircraft. However, Auburn does use a citation jet to move city officials and a Saab 2000 for sports teams. The main thing to know about most reciprocating engines is that they typically burn avgas. This is typically 100 or 100 low lead, which is more flammable, but fire are easier to extinguish with water. If 100 low lead or 100 or any sort of avgas is on fire, so these are going to be reciprocatings over here. This is a lot more flammable, but the good thing about that is that you can put those fires typically out with just plain water. You cannot put out Jet A fires, which Jet A is used by these other turboprops and jet engines. You cannot put these Jet A fires out with water. In fact, water can make the fire worse because the fuel will float on top of the water and continue to burn and spread as the water moves. Instead, you should use a foam or a halon fire extinguisher to put out the Class B fire. ABC extinguishers are not recommended either, mainly because they can cause irreplaceable corrosion to the aluminum components and possible structural failure. If it's last resort and that's all you have is an ABC, it'll be better than water. But just know that if you use these ABC extinguishers, that aircraft will have to have a major overhaul and possibly be scrapped. All right. General K-12 operations. Aluminum will not spark and can be cut with a rescue saw, such as a K-12. Many of you know this, but just make sure you spray water on the rescue saw as you cut, just so that the aluminum does not melt to the cutting device. And an auxiliary power unit, or an APU, is a small jet engine. It sort of looks like up here. It's typically on the tail of most bigger airplanes, such as jets. The APU is a small jet engine used to generate electrical power on a larger aircraft. A lot of engine fires on startups typically apply to these APUs. Moving on to outflow valves. An outflow valve is it's a little hole, and typically again in the tail of the plane. And we'll talk more about outflow valves, but this is kind of what they look like. If an aircraft is having pressurization issues on the ground, such as it can't equalize the pressure, whether that be an electrical issue or mechanical issue, whatever's going on there. But if an aircraft can't pressurize, let's just say you go up to a door and that door will not open. The first thing, do not force open a door that can't open on an aircraft. Typically, what will happen is you need to equalize the pressure in the aircraft. What you'll do is you'll take a picket axe or a pike hook and you'll go to this outflow valve on the back, and there typically be instructions on how to operate it. But I've never done it personally. I've never opened or messed with a outflow valve, but there will typically, like I said, be instructions on how to operate it. If you were not to equalize an aircraft and you were to force open a door on an airplane, that door can possibly shoot out and fatally hurt somebody. So make sure that you do not force any doors on an aircraft. Make sure you first assess it. Sometimes there will be a red light on the inside of a aircraft door that you can look at, and it'll say pressurized and with a red light in the door. So just make sure you do your size up before you just open a door on an airplane. Make sure that you either realize maybe there's a slide that'll deploy, which we'll talk about in the next slide, or there could be a pressurization issue where you have to equalize it. Just making sure you're doing the sides up and knowing that you have this outflow valve to your advantage if you need to use it. Only approach an aircraft from the wheels from the front or rear at a 45-degree angle. We'll talk about in a second about Cirrus's. Cirrus is an interesting manufacturer that's got some hazards associated with it, in which you'd only approach from the front. But in most aircraft, you're only going to approach from the rear or the front at a 45-degree angle, just as you would a land vehicle, because high pressure and temperature can shoot shrapnel to the sides on those gears. Older military aircraft typically use magnesium wheels, and these wheels present the most danger in throwing shrapnel to the sides when exposed to high temperatures. All right, so plug doors. Doors will typically have bold red text on the exterior of the aircraft that will explain any hazards operating that door. Like I said, just don't force open a door on a pressurized aircraft. If it doesn't open, assume it's pressurized. And open that outflow valve with a pike hook or a pighead axe to release that pressure. Outflow valves are usually located at the rear of your fuel sludge, like we talked about. Also, keep in mind doors may have rescue slides that deploy within 5 to 10 seconds. Read warnings on the sides of aircraft and make sure that this doesn't present danger when conducting rescue operations. Some aircraft have red bands across their windows to indicate that these emergency exits are armed with rescue slides. The biggest problem that we find is complexity and lack of standardization can complicate these rescue efforts. So when it comes to opening aircraft doors, just do your best to follow the instructions on aircraft doors and you just use your best judgment when entering an aircraft. Last note I wanted to add on to there was just to make sure if you move any sort of debris or move levers or press buttons, just try to make a mental note of what you moved or what you pressed. Because when FAA or NTSB investigators come to ask questions about the scene and things have been moved, they might come to you and ask you in either an official setting of court or anything. Just try to make a mental note of things that you moved just because they can help prevent these future accidents from happening. This is something that I found when I went to Montgomery, Maxwell Air Force Base. It's a very useful document called the Technical Order, a TO 105E-9. It's a document issued by the United States Air Force that provides instructions for operating and repairing and equipment in vehicles. This TO 105E-9 contains quick reference materials for military aircraft, many general aviation aircraft such as the Cessna 172, which Auburn flies, and for the most part, it does have some other military variants that are very similar to Auburn's aircraft, such as the Piper Seminole is very closely related to the Cessna 310, which is located in this document, and it does a really good job at breaking down these airplanes. I kind of included it here because, as you can see here, the Cessna 172 Skyhawk. It's known as a T-41 in the Air Force, but it's the same aircraft. That's the military variant. This is kind of self-explanatory, but this breaks down this general engine shutdown. So I'm going to talk about more here in a second, the components that goes into this Cessna 172. But this is one of the main aircraft that Auburn flies in their flight program. So when you are exposed to an aviation cockpit, whether it be a Cessna 172, any of the other airplanes that Auburn operates, you want to operate from right to left. If you see the mixture control here, this controls the amount of fuel that enters the engine cylinders. If you pull this out, you start with that to cut the fuel off in the engine. Then you want to pull out the throttle control knob. That'll idle the engine. And then the ignition switch this is the most important out of all. This will shut down the engine immediately. And if you don't turn this to off, that prop is still, you always treat a prop on aircraft like a loaded gun. If the ignition is not off and the magnetos are not grounded, which are essentially batteries for spark plugs, if those are not grounded by turning this ignition to off, that propeller can spin at any time and crank up and hurt somebody. So move from right to left. So mixture out, throttle out, ignition off, and then turn off the master switch, which is a big red button here, and it'll be a rocker switch, and you'll turn that off, and it'll shut the electronics off to the battery. And then right here, it kind of shows you where the fuel tanks are located in the Cessna 172. It has high wing tanks. And a very important to note about Cessnas is they don't really teach us this in our training, but I went and talked to our safety manager at Auburn, Mr. Keith Williams. This right here shows that there's fuel running through all the posts. Now, it is very important. You want to treat these posts like they could have fuel running through them. So it depends on the Cessna 172 model. There could be other models that have fuel that flows through each post. But from what I've heard and what I understand from Mr. Keith Williams, he's made me aware that only the A post has fuel that runs through it. So the B post is able to be cut through and the C post is able to be cut through. But the A post does have fuel that runs through from the wing tanks to the engine through this A post. Cutting the A post can potentially cause a spark. And like we said earlier, 100 low lead gas is very flammable. So be very, very, very careful with sparks because they do not mix well. Any type of add gas, whether that be 100 or 100 low lead, are a recipe for a not so good day. Here's a Cessna 310. Auburn does not have a Cessna 310, but we have a Piper Seminole, which is very, very similar to this aircraft. Just kind of looking here, it has wing tanks. It does not have this fuel out here, so the Seminole does not have that. But it does have a very similar cockpit layout. Again, right to left, mixtures, props, throttles off, and then the mags will be down here. I'm not going to go over this one a lot because it's it's not the same aircraft that Auburn operates. It's a completely different plane, just as a generally the same layout. But I'll get into here a second about the Seminole cockpit layout. Here is an aircraft overview of the two main aircraft that Auburn flies. So this is the Seminole I was talking about. Here's the Skyhawk or the Cessna 172 and the Piper Seminole. So the Cessna 172 is a 53-gallon aircraft. Fuel is mainly located in the wing tanks like we saw earlier. The door opens from a single latch and it can only be opened if it's locked from the pilot side on the left side looking forward. The doors do open on both sides, but it's only able to be unlocked from the pilot side, but really doesn't change anything if you have to extricate somebody, but just, something to know. Single engine, clearly. Both are reciprocating aircraft. This is a 110-gallon aircraft. Fuel is located in the rear of the engines, back here in these fuel nacelles. There's one door here on the Piper Seminole. On the pilot side, there's only an emergency egress window. So that's the only way that the pilot's going to be able to get out if he's entrapped in his seat. So yeah, there's no door on the left side, only emergency egress window, and then there's a single emergency egress window. Here's the Cessna Citation and the Saab 2000 we were talking about. So Auburn flies two Cessna Citation jets with a team of 6 pilots, supported by a maintenance manager and a dispatcher. They fly faculty and administrators and support athletic recruiting for the school's football and basketball programs with that jet. The Citation carries 870 gallons of fuel, but that is at full capacity. Pilots will normally land with around 300 to 400 gallons. This aircraft is pressurized. However, pressurized, like we said earlier, wouldn't normally be an issue as it would depressurize with weight on the wheels. But if the system does fail, you may need to use that outflow valve in the event of an emergency or electrical failure. There is a main entry door forward of the left wing and an emergency exit behind the right wing. So the Saab 2000 also is operated by Auburn for sports teams to travel on. The Saab 2000 is a twin turboprop transport category aircraft and is designed to carry 58 passengers. However, all Saabs operated into Auburn's airport are set up in a 30-seat passenger configuration. The Saab 2000 carries 1,370 gallons of Jet A fuel and will land with around 500 to 600 gallons. It has 5 exits, 2 in the front, 2 over wing, and 2 exits. It has 5 exits, 2 in the front, 2 over wing, and I believe it's 1 in the rear of the right side. So here's the Cessna 172 cockpit layout. So most aircraft at Auburn are general aviation reciprocating aircraft. So here's the Cessna 172 cockpit layout. You've got the yoke right here, not hugely important. So, but more like we were talking about earlier, working from right to left. So let's just say you're exposed with this cockpit right here. You've got a pilot that's incompetent. So this is the Cessna 172 cockpit layout. Let's just say you're exposed. You come on scene. You see this guy. There's a unconscious pilot, and this is what you're exposed with right here. This cockpit setup. So what you're going to do is, like we said earlier, work right to left. You're going to pull this mixture throttle out. And there's a little button here that you have to press while you're doing it. Push that button in, pull it out, pull out the throttle, and then you're going to turn this ignition key to off, and then turn off this rocker switch of the mastery battery. That will effectively turn off this aircraft pretty much completely. If you want to, you can turn off the standby battery, but that's not a huge concern. Just making sure turning off this main bat is very important. So here's the Piper Seminole multi-engine aircraft cockpit layout. As you can see here, there's two levers for each component of the throttles, the props, and the mixtures. So if you, like we said, right to left, pull both these back first, and both of the mixtures, pull the props back second, all the way back, throttles all the way back, and then the mags, there's no ignition switch, but these are 4 buttons here, 2 for each engine, and just go off and just turn off all these mags here, and that will pretty much turn off the entire system. You could also go off and turn off the emergency battery and the battery over here. It's all right here. But again, if you're trying to extricate somebody quickly or if there's a fire, just making sure you're turning off the engines first is very, very important. So we talked about Cessna, we talked about Piper, we talked about some basic aircraft systems involving fuel, electrics, shutting down the engines. The last manufacturer I want to talk about is Cirrus. So Cirrus has a few airplanes that operate in and out of the airport. Common models of the Cirrus include the SR-20 and the SR-22. These models that were made by Cirrus have some interesting systems that can potentially hurt first responders if they're not aware of how these systems work and how to deactivate them. So the Cirrus aircraft has what's called a CAPS system. It's a Cirrus aircraft parachute system, and it's a rocket-propelled parachute that shoots out of the airplane and is essentially a parachute that brings the aircraft down to the ground when the pilot deploys that parachute. And like I said, it's rocket boosted, so if it's not deployed by the pilot and is still armed on the ground, let's just say the pilot decided to land in a field or on a road and didn't need to use the parachute, which has happened in the past. First responders need to be aware on how to either deactivate the CAP system or how to avoid messing with the armed wire. There's an armed wire behind the pilot, where if that wire is moved even an inch, it could potentially deploy that parachute, shoot off a rocket, and possibly shoot shrapnel within a 1,000-yard radius and hurt somebody. So this video is going to talk about the systems associated with the Cirrus, and then we'll go over the safety documentation with the Cirrus briefly. We'll kind of scroll through and see how to deactivate the system.
It's important to understand how a CAPS or similar parachute system works. In case of emergency, the pilot activates the system by pulling a red T handle. This action pulls a stainless steel cable which activates an igniter at the base of the rocket. The rocket ignites, pushes the compartment cover aside, and pulls the parachute package away from the aircraft at speeds in excess of 155 miles per hour. The 55-foot diameter round parachute canopy then inflates automatically and lowers the aircraft to the ground. Once the system has been fully deployed, the pyrotechnical devices are inert and pose no hazards to first responders. The time to be concerned is when the system has not been activated and the aircraft has crashed or is burning on the ground. It is at this time that the components may still be in the aircraft and compose a burning or launching hazard.
In an accident where the chute is not deployed, it can become a real safety hazard to emergency responders. It's kind of like firearms. We always assume that a gun is loaded. And with the advent of the ballistic recovery system and airbag system, We really need to start stepping back and looking at all these aircraft as if they're loaded.
When an airplane crashes, it belongs to the National Transportation Safety Board. They are the investigative agency that is responsible for that aircraft. They are going to try and get commitment from other agencies and other companies to help support that accident investigation. The agency that they're going to be calling on next is the Federal Aviation Administration. They're the ones that are going to respond out of the field offices, send their investigators to help assist the National Transportation Safety Board members that are responsible.
As a first responder, there are some important things to remember when you encounter a crash site. First, for everyone's safety, make sure the aircraft's engine is shut down. The best way to shut down an aircraft engine is to stop the fuel flow to the engine. Access the cockpit and locate the red fuel control. Pull the control aft to the idle cutoff position. Most fuel controls are red and have star-shaped handles. Others may resemble a large cabinet door pull. You can also move the fuel selector valve handle to the off position. The fuel selector is usually located near the center of the instrument panel, in the center console, or on the left side of the aircraft's fuselage near the pilot's seat. Once the engine is shut down, turn off the aircraft's electrical power. Locate the master switches on or below the instrument panel, above the left cabin window, or below the pilot's left side window, and make sure the switches are in the off position. If the aircraft has a key in the ignition switch, turn the key to the off position and remove the key. If the aircraft is intact and there is no fire, the cabin can be locked for security. Give the key to the accident investigators when they arrive. Be aware of fuel, oxygen, and TKS tanks. Most aircraft carry fuel in their wings or in separate header tanks located above and aft of the aircraft's engine. Some have auxiliary tanks at the wingtips. Aircraft which are being flown long distances may have auxiliary fuel tanks installed in the cabin or baggage compartment. Many of today's general aviation high-performance aircraft have TKS fluid on board to de-ice the aircraft's flying surfaces. TKS fluid is generally stored in a dedicated tank, but aircraft operators have been known to carry auxiliary containers of TKS in places like the baggage compartment or in the backseat of the aircraft. Similarly, GA aircraft that routinely fly at high altitudes may be carrying portable supplemental oxygen bottles on board. Oxygen, like TKS fluid, can present a hot spot in an aircraft fire. Be on the lookout for composite hazards. Many of today's aircraft are made of composite materials and foams that can produce toxic or poisonous gases if they burn. The accident site should be approached from upwind while wearing an oxygen breathing apparatus or an organic vapor mask. Burned composite surfaces may disintegrate to the touch and may not support your weight. Extra care should be taken to protect yourself from composite dust, sharp needles, and shards of composite materials in the aircraft wreckage. Treat composite cuts or abrasions immediately. Locate and identify all components of the caps or ballistic parachute system. Look for the rocket canister as well as the igniter assembly. The rocket canister is a red canister about the size of a 16-ounce beverage can. When you locate system components, always consider them as live ordnance. Don't handle them, and keep heat or flame away from them if possible. Mark the components to remind other first responders to stay away from them, and call the Cirrus hotline at 800-279-4322 immediately. Air safety personnel at Cirrus can help you determine what risks are present and will send trained accident personnel to assist you with disarming any and all safety systems in the aircraft or wreckage. While searching for these components, stay clear of the rocket's potential flight path, which is aft of the rear of the aircraft. The area after the rear cabin window is where the rocket is stowed on Cirrus aircraft, so rescue personnel should approach the aircraft from the front or sides. The rocket exits the compartment at about 155 miles per hour and poses a significant impact hazard to personnel for the first 60 feet of travel. Most of the rocket's energy is spent within the first 100 feet of travel. However, inertia could cause untethered components to travel up to 10,000 feet in 1.2 seconds. An emergency locator transmitter, ELT, is required equipment for all certified general aviation aircraft. ELTs automatically transmit a locator signal to the U.S. Air Force search and rescue facilities if the aircraft experiences a sudden impact. you may be asked to locate and turn off an ELT at an aircraft accident site. On the Cirrus and most recent production aircraft, an ELT shutoff switch can be located on the instrument panel. If the ELT has been activated, a small red light next to the on-off switch may be flashing. Simply press the black button to switch the ELT off. Never cut into the top of the aircraft or the area from the top of the doors to the baggage compartment, as this is where the CAPS activation cable is located. If this cable is pulled or dislodged more than 1/4 of an inch by cutting or penetrating gear, the pull of the cable could set off the rocket igniter and deploy the rocket. If the CAPS system has been deployed during high wind conditions, the aircraft could be dragged downwind after it touches down, posing a hazard to personnel and objects on the ground. The best thing to do in this case is to collapse the large canopy by spraying it with water from a fire hose. Once it is collapsed, park a heavy vehicle on the canopy to stabilize the aircraft from further movement. The other potential hazard you may encounter involves the AAIR, or MSAFE Aircraft Inflatable Restraints. These restraints work like an airbag to protect aircraft occupants from injury to the head and body. On a 3-point system, the airbag itself is attached to the lap belt, while on the 4-point harnesses, the airbag is located inside the outboard shoulder harness. Both systems use a heavy leather shroud to protect the airbag itself. The danger in this system comes from the fact that it uses compressed helium to inflate the airbag. Like the CAPS system, you must always assume that the system is live unless you see that the airbags have been deployed. Cirrus works closely with the National Transportation Safety Board to maintain an accident investigation team that's ready to respond to any Cirrus aircraft accident 24 hours a day. Although each system's installation will differ slightly, all ballistic parachutes and MSAFE AAIR airbag systems will operate by the same principles and will use the same basic components. That's why it's important to know what to look for.
Think about these things. We have to assume that it's got a system on board when we go out to an accident, rather than be surprised by when we find one. I think that's the key. And then what do you do? How do you deal with it? Who do you call? And of course you have to identify and notify. That's the policy. Identify that you have a rocket and then call somebody that can help you. Cirrus will be glad to help you.
The next time you respond to an aircraft accident or fire, consider that the aircraft might be equipped with a ballistic parachute and AAIR restraints. Proceed accordingly by approaching from the upwind side. Identify and locate all components. Assume the systems are live unless visibly deployed. Keep heat and flame away from the site. Remember the no-cut zone on Cirrus aircraft, and most importantly, contact the Cirrus Air Safety Department immediately. And finally, qualified personnel should remove all hazardous components from the aircraft wreckage before it's transported from the accident site to the salvage yard. We're committed to your safety, and we're here to help.
So yeah, that was an awesome video by Cirrus. They kind of summarized everything that we needed to know when we're operating around the scene at an accident. I kind of clipped up the video a little bit and played the more important parts because, you know, they talked about some background for some of the employees, which I kind of cut out. But if you guys want to see the full video, I'll try to share a link in the email that gets sent out with this training. And I'll make a folder of all the documents that, you know, kind of summarize what we talked about today. But here's the Cirrus website that's literally here for first responders. It's got safety documents. It's got videos. The one we just watched is right here. The Cirrus video where they talk about the basic systems, how to shut down engines and all that. And then here's the hotline number that they talked about. So if we were to experience a Cirrus disaster, here's the phone number. Like I said, the hotline number. If we had any questions, we can call them. And then here's an email if we had follow-ups later on. Here's safety documents, which I'm going to try to download these and send them out as a part of an email for this training. They have the Vision Jet, which it could happen where one of these comes into Auburn. Just it's not very common for Vision Jets to come in and out of here. Maybe for game days or business people that want to come in, they'll use the Vision Jet. But these are more common. The SR series, like I talked about earlier, the SR20 and the SR22. There's a first responder info manual right here, and it kind of just goes over. It goes over all of the air safety summarizations. It goes over the cap system, how to disable, securing, disabling caps. This would be the more important section to kind of go over. So, I'm not going to go over this in this presentation. If you want to, I'll share these documents. But it just goes over basics on how to disable the cap system, and has oxygen systems in here. Everything you need to know, just in one document, pretty well laid out. What pliers cutters to use, so you're not pulling this Cirrus activation device for the cap system. Because like I said, if you pull this, it could potentially deploy that. So, just important notes there. Now we're going to get into some of the alerts. So we have alert level 1, which will be a low probability of an aircraft crash. So let's just say a multi-engine aircraft has one engine's out, overheated engine, oil leak, etc. So if there's a low probability of a crash, we'll do an alert 1, and that will stage an Auburn fire engine with foam capabilities and a Opelika fire engine with foam capabilities to the incident command, which will be on the Bent Creek side on the FBO ramp. Then we have alert 2. Alert 2, we have a high probability of an aircraft crash. Aircraft is approaching the airport with an engine on fire, loss of hydraulic pressure, faulty landing gear, etc. This one's a little difficult to go over and execute because there's a lot of different areas that these trucks have to be, and they have to be in certain spots. With alert 1, there's a low probability of a crash, and we're just going to have 2 trucks that stage on the incident command over on the east side of the airport at the incident command. With the alert 3, which we're about to go over here in a second, that'll be an aircraft has actually went down and crashed, and all we have to do in that scenario is just go to the crash site. With alert 2, which is this one right here, this is the one where we'll have to stage trucks at certain spots around the airport, around depending on which runway. That may be radio information that the supervisors there tell us. Maybe we know they're coming in on runway 1836, which I'll tell you right now, 1836 is by far the most popular runway at Auburn. There's 2 different runways. There's 1836 and 1129, and we'll go over these in a second. But 1836 is a lot bigger. It's just everyone uses it. 1129 is a lot smaller of a runway. It's got a little bit of a hill to it and bumps in it, and not really many people use 1129. I would assume if an aircraft's coming in with a problem, it's going to be using either runway 18 or 36. And like we said, 1836 is one runway. So we'll typically most likely respond like they're going on 1836 unless we have wind information or someone's telling us that they're going to be on 1129. I'll go over how to stage here in a second because we have a SOG that goes over this, but I've taken it and made it visual so people can kind of see where they need to go. And the goal is to print these off in the trucks so that people can have them at their disposal. Our alert 3 aircraft has actually crashed at the airport. So here's who will respond to that, and they'll just respond directly to the crash. Medical alert. So, someone has a medical emergency, this is who will respond. More on the dispatch side of things there. Here are the actual 3 buttons that the airport staff has. So if an aircraft has actually crashed, they'll press the red button and it'll go through as an alert 3. Then we have emergency standbys and medical emergency down here. And this is the actual picture of these buttons at the Auburn Airport. All right, directly from our SOGs, aircraft crash, red. This is our responsibilities. Then the airport administration responsibilities. You can read it off the slide there. Pretty self-explanatory. Airport standby. This is typically, they'll press this the most. So smoke in the cabin, light not working in the cockpit, gear not going down. This is the most common call we'll get at the airport is an airport standby. And again, this is directly from our SOGs, our responsibilities, airport administration responsibilities. All right, and then now we'll walk through what an alert 1 is going to look like, as well as look at the airport a little bit. An alert 1, like we said, is a low probability of an aircraft crash. So I'll draw it out here. Pen. So here's Auburn Airport. Here's Aviation Way right here. And there's Bent Creek. So when we're coming on the airport, we're going to bring 2 trucks through this little fence here, and we'll stage, this will be incident command right here. We'll stage 2 trucks there, one from Auburn, one from Opelika, and that's how we'll run an alert 1. And let's just look at the airport for a little bit. Clear that. All right. So we'll draw. Yeah, there we go. All right. Here's 18 right here. An aircraft will come in, landing on runway 18. And then here's runway 136. So they'll come and land right here. That'll be runway 36. So it's the same runway, but just what direction you're heading. Here, right here. Here's what I like to think about Auburn's airport. When you look at it, there's Alpha right here. Alpha runs all the way down here, all the way parallel, the whole airport. I like to think of it as Auburn is on the Alpha side. So Alpha right here will be on the Auburn. So A is in Auburn. And then there's B over here, Bravo, and C over here, Charlie. Runs like that. Shoot. Let's erase that. Charlie. That's Charlie. And all these, that's Charlie 2, that's Charlie 3, and then this is Bravo over here. Charlie. And then this is Alpha. So Alpha's on the Auburn side, B, Bravo, C, Charlie, as in Bent Creek. So Bent Creek is on the Bravo Charlie side. And this is Alpha 2, this is Alpha 1, this is Alpha 3. And yeah, that's what the airport looks like. And we already went over how Alert 1's going to look. This is the incident command right here. We'll stage 2 trucks there with phone capabilities. All right, moving on to Alert 2. So Alert 2, this is what the SOG looks like from our SOGs between Auburn and Opelika. Here's what our airport diagram looks like. I've taken that and I've drawn it out so it makes it a lot more clear, and hopefully we get these in the trucks printed out. Opelika is going to stage at the beginning of runway 11. Auburn is going to stage at Bravo, right midway point at runway 11. And Auburn is going to stage on the Tango over here, and it'll be on the beginning of runway 29er. So all of this is runway 1129er, but Opelika is going to go there on Alpha. Bravo is going to have Auburn there, and then Auburn will also stage on the holding short area of runway 1129. And then right here, we see the ILS critical area. So if we go back, the critical area is sitting right here. This is the critical area here. I'll tell you right here not to cross that unless you have clearance. As you can see right here, this little dot right here, that's ground landing equipment. And what it does is it sends glide slope information to the final of runway 36. Which means if you are bringing your truck over here, I'll draw this in blue. If you're right here and you cross this ILS critical area, you're blocking that glide slope information. That's why we have the critical area for no one to cross unless they need to. Just some information there about the instrument landing system critical area. Alert 3. Like we said, an aircraft has crashed on or near the airport. The biggest thing to take away from Alert 3 situation is the utilization of an airport grid map, which is this right here on the slide. We'll use this map to relay where the accident is located on the airfield. All ARF departments use these grid maps, and this grid map has been stressed in the safety meetings we've had at Auburn. So let's just say, for example, an aircraft goes down and it goes down on Charlie 2. So Charlie 2 is going to be, like we said, over here on the Bent Creek side. It'll be right there. If an aircraft goes down, let's just say right on Charlie 2, instead of the tower saying, emergency vehicle runway went down on Charlie 2, what'll happen is they'll say aircraft down on 3 Charlie or Charlie 3. And you're going to take this grid map and you'll pinpoint where Charlie 3 is, and it'll make it a lot easier. Instead of, and even for example, if they went off the airport over here somewhere, they can just say it's on Echo 5, and then we can use that to identify where the aircraft went down. And hopefully dispatch relays that to us, so we'll know ahead of time where exactly to go. But once the tower comes into effect, they're going to start using these grid maps, and we'll have these to help locate the aircraft. I already talked about runway 1836 right here. It's a lot busier. Everyone uses it. No one really uses this runway right here. It's used sometimes depending on the winds, but typically runway 1836 will be used. And then we're working on getting these maps in the trucks. Once the tower control tower is built, we'll need to then communicate that to the tower to make sure they're also on the same page as using those. Taxiway Bravo up here is going to be the quarantine area for aircraft. This is where we'll order aircraft that are blocking traffic to stand by. I just have this here to kind of look at the whole airport from a bird's eye view. All right, get the drawing pin out. Make sure that we know all this information right here. So we've got Auburn's flight school right here. This is Auburn, their flight school on the Alpha side. And then we've got, again, Bravo over here, Charlie over here. FBO is right here, the fixed base operator. And this will be your incident command right there. Our incident command will be in this area. And the critical area, we already talked about that right here, making sure that we're looking out for that on the Charlie side and not blocking that glide slope information. We talked about where to stage. So for an alert 2, we're going to have Auburn stage on this Alpha right here. So let's just clear this. We'll have Auburn stage right here. So we'll have an Auburn unit there. We'll have an Opelika right here. And then we'll have another Auburn unit over here on Tango, holding short of runway 11. That'll be for an alert 2 on runway 1129. Clear that. So for runway 1836, we'll have 18 over here. So this is 18. And then we'll have Opelika stage before 1836 right here. Let's just draw this out. Runway 1836 is right here. So we'll have Opelika right here. Okay, let's see. Opelika is going to be right there, holding short on Bravo. And then we'll have Auburn on Alpha 2. And then Auburn holding short of runway 36. Right. Really hard to draw this thing. There we go. And that's how we're going to run that. And then we'll have at the incident command, like we said over here, we'll have a ladder truck with rescue tools from Auburn Fire. We'll have a ALS transport or fire engine from Opelika Fire. And then we'll have 2 shift supervisors from both Auburn and Opelika, as well as an ALS ambulance and EMC ETS stage there as well. And like we mentioned, we have this road running over here. Let's see, it kind of runs off the screen. But we'll most likely, if they're coming on 3.6, we'll stage a vehicle right before final over here on this road, or on a road over here, just in case they were to stall. And sometimes when aircraft lose an engine, they may stall on final because of how slow they get. So we might end up staging a vehicle right before final, just in case that aircraft were to stall or before they come into land. And some other important information, media affairs, this was the address for that. So Auburn University Human Resources, there's the address there. And overall, just make sure the scene is secured. No patients are shown in any pictures, media, or other news networks. Try using tarps or blankets, and even consider shutting off airport roads, such as Bent Creek Road or other roads, like we talked about Aviation Way, ground control. And this is a university airport with a university-run flight school, and pictures and media are very sensitive, and the university does not take that lightly at all. They prioritize people's privacy just like any other university would. Prevent any pictures from being taken or spreading, and keep information to yourself until the university wishes to disclose any of that information. NTSB notification procedures. This is just some technical stuff. So if a fatality occurs, the National Transportation Safety Board, or the NTSB, is the responsible agency. Incidents not involving a fatality and aircraft weight less than 12,500 pounds may be delegated to the FAA. Just in case anyone asks you questions on scene, that's just how that works legally. Wreckages, release, and removal. Aircraft wreckage after the scene has been controlled should not be tampered with or moved until released by the FAA or NTSB, and aircraft belonging to the U.S. Armed Forces may not be moved without DoD approval. To wrap up this presentation, I just wanted to add a little bit extra for flight students to take note of, and something for us as first responders to also take into account. In training, pilots are taught three main things in order of importance, which is aviate, navigate, which always comes first, and then communicate. As a part of aviate, navigate, pilots will try to find unpopulated areas and possible roads, which may complicate response efforts from a first responder standpoint, but will also minimize danger for anyone that's on the ground. For any pilots that may be tuning into this, just do your best to get done your emergency checklist and open your door if possible, which is a very important item on most checklists, is to open up your door before you make impact, so that if you were to be conscious, then you can get yourself out of the aircraft if there were to be a fire on board, rather than us having to take those precious minutes to get there and extricate you, which, if your door is shut, it could potentially be bent and harder to open. So just try to get that door open if you can. And lastly, just communicate your general location and souls on board, and providing a tail number and fuel, which will all help with rescue operations. And to wrap up here, I'm not going to play this video. It's about 15 minutes long by the FAA. I'll link it to the video that I upload. It's a great video. It talks about everything that I've just went over, but it goes a little bit more in depth. The audio didn't come through when I tried playing it, so we'll just link it to the presentation that gets uploaded. But I recommend watching it. And if anyone has any questions, like I said, you can email me at my work email, pstavros@auburnalabama.org, or just send me a text, 678-693-3643, and I'll do my best to respond.